Hi, everybody. Welcome to Perfect eLearning YouTube channel. I hope you guys are doing amazing. And in this particular video, we are going to understand a very important topic for the interviews, and that is data structures. And we are going to actually understand that practically by implementing one of the interview questions that is usually asked in almost every company, right? So I'm going to walk you through what the question is. All right. So this is a question wherein you have been given an array, okay? An array that is going to contain n integers. N could be any number, 0, 1 to 5, any number. It could be positive, it could be negative, it could be 0 as well, right? So you need to find the product of the maximum product subarray. So given the array of 5 numbers, you need to give me the maximum product subarray. For example, if I have given n as 5, so my array, for example, is 6 minus 3 minus 10, 0 and 2. The output would be 180. How? Because that is the subarray with the maximum product, which is the subarray 6 minus 3 and minus 10. So the output, if I multiply 6 into 3 into 10, so the answer comes out to be 180, which is the maximum product subarray, right? So this is what you guys have to do. So at this point of time, I want each one of you to please pause the video and try to do this question on your own, and I'm very sure you guys can do it. And then come again to see the complete video.
Hey everyone, welcome back to Perfect eLearning. In this video, we are going to solve a very simple problem, that is maximum product subarray. Here, we are given an array that contains both positive and also the negative integers. We need to find the product of maximum product subarray. And the expected time complexity here is O of n, and O of 1 extra space can be used. Here we need to find the product of maximum subarray, which can be obtained. Here we need to find the maximum product subarray. Subarray indicates the element must be contiguous, that is consecutive elements. We need to find the consecutive elements of an array which results in maximum product. Coming to the first test case, the array elements are 6, minus 3, minus 10, 0 and 2. And the output is 180 because the required subarray is 6, minus 3 and minus 10, the first three elements, which results in 180, that is 6 into minus 3, which is minus 18, and minus 18 multiplied with minus 10 is minus into minus plus 180, which is the maximum product we can find out. Coming to the second test case, the array elements are minus 1, minus 3, minus 10, 0 and 60. And the output is 60 because the maximum product subarray in this test case is 60. Even though we multiply 60 with minus 10 and minus 3, we also need to multiply with 0, which returns the value 0. Coming to the next test case, the elements are minus 2, minus 40, 0, minus 2 and minus 3. The maximum product subarray here is the first two elements, that is minus 2 into minus 40, which is 80. So we return the output as 80. Multiplying with any other elements results in another product, which is not the maximum. Before directly jumping into the solution, we need to find two observations here. When forming the maximum product subarray, we need to maintain two variables, that is the maximum product so far and also the minimum product so far. We also need to maintain the minimum product so far because let us say if the minimum product so far is minus 900 and we multiply the minus 900 with a negative element, it becomes positive. That is, it may also become greater than the maximum product so far. So we need to keep track of both minimum product so far and also the maximum product so far, because the array also has negative elements and the minimum product cannot turn into the maximum product. So without any delay, let's take the input of numbers. Array is equals to 1, comma, minus 2, comma, minus 3, comma, 0, comma, 7, comma, minus 8, and minus 2. Let us say this is the array. And first, let's find out the length. I'll zoom it in so it's more visible. Yes. First, let's take the length of array. N is equals to length of array. Length function returns the length of the given array. As discussed, we need two variables here, max so far, which will be initialized to the first element of the array, and also min so far, which will also be initialized to first element in the array, and the result which we will be printing, that is the maximum product subarray. Let us also initialize it to the first element of the array, that is the element at index 0. Now let us write for loop for traversing through the remaining elements, that is from index 1 to index n minus 1. So for I in range of 1 to n, as this n is exclusive, we only go till n minus 1. Let us take a new temporary variable which stores the maximum value so far. So temp is equals to maximum of, let us give an array of values, let us say, which will be the current element itself, and then the current element itself multiplied with the maximum sum so far, max so far, and also the current element multiplied with the minimum so far, min so far. Perfect. Now we also need to find the minimum product so far. So let us write minimum so far is equals to minimum of, let us give the array, that is the current element, and also the current element multiplied with the maximum so far, max so far. If the current element is negative and multiplied with max so far, it becomes the minimum element so far. Let us also give array of I, that is the current element, into the minimum so far, min so far. Perfect. As the temp variable stores the maximum so far, let's change it here. Max so far is equals to temp. Here, the result variable contains the maximum product. So we need to take care of it. In the current loop, the maximum product so far is stored inside the maximum so far. So we need to change this with result. We need to check if result is smaller than maximum so far, then we need to update it. So let us write result is equals to maximum of result, comma max so far. And finally, let's print the result. Print result. Let's run the cell and let's check out what is the answer we are getting. It's 112, perfect. Minus 2 into minus 8 is plus 16, and plus 16 multiplied with 7 is 112, which is the maximum product we can obtain. So this is how we find the maximum product subarray using two variables, that is minimum so far and the maximum so far. The main logic of the program is we need to find the both minimum and maximum so far, that is up to the current index, because minimum product up to now can also become the maximum product if multiplied with a negative number, and the maximum product can also become the minimum one if we multiply it with a negative number. So we keep track of both minimum so far and maximum so far. Hope you all have understood how to find the maximum product subarray. Thank you everyone.